Welcome to S&C's Power Up webinar on moving beyond average reliability metrics. My name is Spencer Zirkelbach, and I will be your host for today's webinar. And I want to start off by saying thank you to everyone who has joined us here today. We have a wide range of attendees from utilities, government, regulators, and consultancies from around the globe. We want to make this webinar a great use of your time, which we believe starts with getting our audience's input on today's topic. And we'll be doing this using a few different polls throughout the webinar that we encourage you to participate in. I'm going to start off one with right now that you should see as a pop-up. To start, there are a lot of acronyms when it comes to power reliability metrics and want to gauge how familiar everyone in the audience is with some of these terms. I've shared a polling question and encourage all attendees to complete it. As you answer that, I have a few administrative items I want to cover. First, this webinar is being recorded and the recording will be shared after the event along with the associated white paper and a survey to get your feedback. All attendees' microphones are muted and we have turned off the chat feature to try to streamline communications. Please use the Q&A function at the bottom of your screen to ask any questions you have throughout the webinar. We will address all questions at the end of the presentation. If you have any technical difficulties, you can also use the Q&A function and a member of the S&C team will help. Now that we have those items out of the way, let me introduce our panelists who will be sharing their expertise with us today. Chris McCarthy has focused the past 25 years of his career on electric utility distribution systems and is currently Vice President, Sales Enablement at S&C. Brian Levitt is the author of the book Energy Resilient Buildings and Communities, A Practical Guide, and is a Regulatory Affairs Director at S&C. We are also extremely pleased to be joined by Ron Critelli, who is the Senior Director of Power Delivery, Engineering, and Technical Services at Florida Power and Light. Ron is not only responsible for FP&L's transmission, substation, distribution facilities, but also serves as FP&L's Section Chief of System Information and Performance during storm season. I want to thank all of our panelists for sharing their time with us today. Now, let's talk about the poll results. I will be sharing these with the group, and it looks like that a predominant number of our attendees, 97%, recognize SAIDI and 95% recognize SAIFI. Followed by that, we have CAIDI at 78% and MAIFI at 71%. The lowest recognized reliability metric is the SEMSMI, which is good and leads us into our discussion today. With that, let's get started with our content, and I'll turn it over to Chris McCarthy to start the presentation.
Thanks, Spencer. Yeah, that was a good intro. SAIDI, SAIFI, CAIDI, MAIFI, those are the common ones that people know. So that's what we're going to start here. We're going to start with a presentation in 3 parts: past, present, and the future, which you'll all see on all the slides in the lower left-hand corner. And naturally, we'll cover them in that order. After the webinar, we'll send you a white paper, and it goes into more details. But for now, I'll highlight just a few things as we look back over the past 5 decades in terms of reliability metrics. So there's been a long history of work to understand causes and impacts of outages on electricity grids. The first used metrics developed in the early 70s were SAIDI and SAIFI. They measure the duration and frequency of power outages. SAIDI and SAIFI have always been the core metrics since that time, and they're still useful today. Next milestone was around 1988. Work began on the first commercial outage management system in an effort to move away from manually managing paper tickets to automate that. So that was a pretty big step in starting to standardize the indices that were being used and also getting more commonality in how the outage data was collected and analyzed. Next milestone that we're going to talk about here, IEEE had work going on with reliability metrics from about 1989 with the important 1366 document, which is the Power System Reliability Indices. That was first published in 1998, and it became a standard, IEEE standard, in 2001. So this is the main industry reference for reliability metrics, but it doesn't cover all the things that utilities are looking into, and we'll touch on some of those today. One of the key things as we reflect on the past is the shift from utility-centric metrics only to the introduction and adoption of more customer-centric metrics after the year 2000. So for any index that you see today that has the letter C, which stands for customers, it's intended to be more granular in how it measures how outages affect individual customers instead of general averages. But stay tuned and we'll tell you which reliability indices we think are better or more useful than others. I'm going to build a chart here that you're going to see a few times throughout the presentation, and we'll add more to it as we advance through the material. The vertical axis is the level of impact from individual customers to feeder levels that affect many customers to a broader system-wide event that affects many feeders. The horizontal axis is the duration of outages from momentaries, which could be less than 1 minute or less than 5 minutes, depending on how it's measured in the local area. And then there's the typical outages in the middle, which is 5 minutes to a couple hours. And then there's the very long outages. Now, we've already established that the core metrics over time have been SAIDI and SAIFI. These are measuring the typical 5-minute outage, 5 minute to a few hour outages, and they're recorded at the feeder level. Of course, utilities may aggregate the SAIDI and SAIFI levels to operating regions or maybe the entire utility service area. And then these simple and direct numbers give you an immediate understanding of the broad performance for electrical service for that utility. If utility only publishes 1 or 2 numbers on reliability, it's these, typically these. In many cases, the presentation of SAIDI and SAIFI is done with major event days excluded, like hurricanes, tornadoes, other massive storms that affects a big part of the system. And by excluding those major events, it provides a better look at day-to-day operations and how that affects reliability. But you do need to consider the indices with major events when considering system resilience, because the big storms still keep happening. Now onto MAIFI, which is another one of the poll results, a common one. MAIFI is a common metric today, and it's been around a long time. But really the data collection for getting anything close to an accurate read on this was not available until more recent years. With more use of radio communication to field devices to get the data, upgrades to computerized outage management systems instead of using paper tickets, and then automated meter reading really surfaces a lot more data these days. One more thing about the chart here, the size of the circle is the relative use of the utility use of this metric. Please note that this is meant to be illustrative. There's 3,000 utilities in the US alone, and there's many different ways utilities are tracking and reporting reliability. This is a way to represent our interpretation and understanding of how the industry is using reliability metrics. One more index looking back here is CAIDI. And notice that CAIDI is not explicitly included in our chart. And I'd like to have a short sidebar on this index. In a few minutes, you'll see many metrics that have C at the beginning, meaning that they're customer-centric metrics. But CAIDI is not a customer-centric metric. It's simply the ratio of 2 system average metrics. So in my view, this metric is really misnamed. It should be something like average restoration time for the system. But unfortunately, this metric has been popular with utilities and regulators for a long time. But today, it's increasingly seen as a problematic measure of reliability. And I'll show you a couple quick examples of how that works. Say we have a base case for a utility here, and they've got 80 minutes of SAIDI, 1.2 outages per year for SAIFI. We do the math, and CAIDI 66 minutes, or minutes per outage. Now say the utility goes on reliability improvement efforts, and they put in automation, they further segment circuits, even underground circuits. SAIDI and SAIFI both improve, but it depends on the ratio of how things improve, because you do the math here, and CAIDI goes up. It looks like you're going the wrong direction. And then the other example is, say, utility doesn't doesn't really even try, and they just let the feeder breaker operate for even small outages. You wait 10 minutes, close the breaker back in. You know, the outages are short, but they affect a lot of people. And depending on the ratio of how that comes out, that could be reported as an improvement in CAIDI. So it doesn't always work like that, but I've seen this too many times to really want to have CAIDI as a good metric of what's happening here. All of the other metrics that we're going to talk about, they accumulate the effects of outages over the course of a measurement period, usually a year. All of the other metrics that start with customers are actually customer-centered metrics and can report on the actual customer experience. CAIDI is more of a misdirection. It's really just the ratio of two otherwise good and independent metrics. So we will move on without CAIDI. The main idea of our presentation today is to dive into these feeder level average metrics to see how useful they really are to the utility business and for the experience of electricity users. So to start with that topic, Brian will have a poll for you.
Thanks, Chris. Yeah, so if we're going to think about the right utility metrics to use, we have to think about how they're used. So there's a poll that's coming up on your screen now, and it's really asking from the utility perspective. And I know not all of you are utilities, but let's think about this from the utility perspective. What do you think the most valuable use of a reliability metric is? This is really about level setting, understanding how this audience believes utilities can best use the metrics today before we start in on talking about what the metrics might look like in the future. We've heard the old adage that you can't manage what you don't measure. So as we think about reliability metrics today, what are they helping us measure? Is it regulatory compliance, customer experience, overall system performance, or identifying areas for specific performance improvement? Maybe Spencer can put up the results in a second here so we can find out what you folks think. Okay, so the votes are really spread out amongst the different answers, but it is interesting that the most folks think that targeting areas for system improvements is an important one. And I think one thing that we can understand, having heard Chris's discussion of the metrics in use today, is that what we have today probably doesn't get us, is not ideal for that purpose. Let's talk about why. So on this next slide here, you'll see that if these are our priorities, we can think about our current system level metrics and how they get that job done. The first problem is that we have a portion of our outages that are simply outside of our data set. Typical reliability reporting excludes outages under 5 minutes and major event days, usually due to big storms or other external factors that can bring the grid down for days. The theory here is that we want to look at whether the grid is generally reliable. Short momentary outages from a branch hitting a power line isn't considered a major problem, so we ignore momentaries. A storm event is outside of a utility's control, so we ignore major event days. The problem is that we end up with metrics that look at one aspect fairly, but can ignore the actual customer experience to a great extent. It should also be noted that there are things utilities can do to reduce momentary outages, as well as bolster resilience for storm response. So excluding those doesn't help us prioritize addressing those challenges. The second problem is that data aggregation involved with capturing feeder level data gives us an inaccurate view. If the grid as a whole is doing all right, but there are a few problem areas, SAIDI and SAIFI don't tell you that. Also, when a utility is attempting to improve SAIDI and SAIFI, it may be more cost effective to take a customer with good reliability and give them outstanding reliability, as opposed to taking a customer with bad reliability and giving them good reliability. The averaging out of all this kind of means we lose the trees for the forest. And so that has been a challenge. Ron, how has the FP&L utilized metrics that are out there today? Off mute, Ron, if you could.
Oh, there we go. I'm sorry about that. So in Florida, I just want to point out we are underneath the 1 minute rule. So we are not underneath the 2.5 minute rule as outlined in IEEE 2.5 beta. So an outage for us is anything greater than 60 seconds. So when you have that type of definition, your approach to problem solving and how you look at your system to drive down the reliability metrics is completely different. A little bit of other thing too about the Florida system, we are predominantly an overhead system. So whether we have overhead feeders as a majority of our feeders, and our majority of our laterals are also overhead. So when I take a look at the indicators, is directionally I take a look at SAIDI, SAIFI, and MAIFI is directionally where are you actually heading? And are you getting better or are you getting worse as a system? The other thing I like about the SAIDI, SAIFI, MAIFI metrics, especially SAIDI and SAIFI, is there are a lot of benchmark industries out there. You can actually start to see how you actually compare to everybody else. Now, why is this important to me? As Florida inherits a lot of customers from other utilities, I need to try to understand their customer expectations. So if they're coming from the Midwest, from the ComEd system or the Con Ed system, I need to understand what metrics what their expectations of electricity requirements are in order to understand that these will be our customers, and then how do I actually meet their needs? So I think benchmarking can provide a lot of insight in that area. When you take a look at it, you're absolutely right. Feeder and laterals are really driving your SAIDI and SAIFI metrics. And I do agree with you. It does, though, mask specific customer issues and needs or problems on the system, along with lower level tickets. So if you're also looking at the cost of providing service, a majority of our cost starts to be around our lower level tickets. So by focusing on the SAIDI and SAIFI, you could actually be losing some opportunities on cost savings. Now, for how we've gone through our reliability journey since 1997, in 1997, we hit an all-time peak for us at 147 minutes. And as you can see throughout the chart, the end of this year, right now, we're going to probably predict to come in at about 53 minutes. So directionally, you can see that we've actually really improved our system. How have we done this? Of course, you have your traditional reliability programs, but really a lot what we have developed and really invested in is in the smart grid devices, not only on the feeder backbone, but also on the smart grid devices on the laterals. On the lateral improvement, since we've moved smart grid devices there, that has improved directionally our SAIDI about 10 minutes. So you can get some really big bangs for the buck on that. Along philosophical differences or changes that you can actually make, when you start to look at fuse saving versus non-fusing schemes, by the use of the technology that actually has allowed us to change that philosophy to move away from the fuse saving scheme to use the smart grid devices like the Trip Saver 2 on our laterals. Now, what has that done is actually really helped our MAIFI indicator also. And of course, we've really honed in on our restoration improvements, and by also creating a smart grid diagnostic center so we can actually start to get into a little bit on the predictive. So when you start to take a look at everything that we have done with our metrics, not only have we lowered our metrics over the last 20 years, we're also driving down a lot of our operating costs, which is also an important key factor that gets left out a little bit when you just focus too much on the reliability indicators. So that's kind of what we've done over the last 20 years that I've been involved with reliability at FP&L.
Thanks, Ron. Yeah, and the SAIDI chart really shows that it's still an important metric. It's still a good benchmark that people use, and focusing on that is still good. But now I'm going to transition to the enough of the 50-year rear view mirror. Let's move on to what's happening now in the present tense, and you see that in the lower corner there that we're going to be in the present for a little while. So everybody knows that we're a more digital society now, and that technology and innovations are changing the way we produce and use energy. A wide range of devices by residential and commercial customers are sensitive to short and long interruptions. So real quick, residential customers are increasingly irritated by the loss of internet connection, video streaming. Things like air conditioning became more important as people were working from home and schooling at home during the pandemic. Manufacturing relies more and more on automation, software, sensors. Any power interruption can lead to production stoppages, and the more complex the machinery, longer time it may take to resume production. Retailers and restaurants can't process transactions when registers go down. Many of the payments are digital and rely on constant connectivity. Delays in restoring power basically result in lost sales. So I think the quote from Manny Miranda from FPL really sums it up in a simple statement that every customer minute of interruption counts. It doesn't matter who the electricity user is, an outage affects every one of us in a significant way today. So back to our chart. While utility reliability is typically reported and published at a system-wide level, each customer's experience of reliability is unique to their location. The average system-wide performance measures mask wide differences in reliability and create a disconnect with what the utility is reporting and what the customers are experiencing. So the best picture of this problem cannot come from the system averages alone. We need to shift to be more customer focused. I'm going to show three metrics that we've seen in the industry use. CEMM, customers experiencing multiple momentaries, is a customer-centric version of MAIFI. And momentary outages are really important, must be included in any reliability measure today, because so many aspects of business and home life and schooling rely on continuous internet connectivity and products that run on electricity. So this metric is customers experiencing multiple momentaries. So if your house had 6 momentary interruptions over the course of the year, even though the system average was 3, it would show up here and you would have a 6 attached to your residence. CEMI, SEMI, customers experiencing multiple interruptions, is a customer-centric version of SAIFI. And CELID, CELID, is a customer-centric measure of customers that experience long interruption durations. So out of these three, there's some usage in reporting of SEM and SEMI in the US, but not much reported on CELID. Scandinavian countries, as an anecdote, have adopted strong incentives for utilities in the form of penalties for customers that have outages that are 12 hours or longer or 24 hours or longer, since an outage in winter in Scandinavia can quickly become dangerous. So each of these customer-centered metrics are more granular than the system averages, and they start to tell a different, more clear story about customer expectations and experiences. So here's a great example of how the average metrics obscure the customer experience. It's SAIDI by feeder from a British utility. The average SAIDI is 45 minutes, right here, but very few customers actually have a 45 minutes SAIDI. Instead, the majority of customers are actually in the less than 15 minutes. Probably a lot of those are at 0. And then on the other end of the spectrum, 8% of the feeders are more than 3 times the average. So it just shows that the average reporting 45 minutes is not really saying what the typical customer is seeing. So this is an example from a British utility, but I know Ron has some good examples from FPL as well on this topic.
Okay. So when I take a look at SEMI and SEM, these are the indicators I really look at when I looking to drive performance at Florida Power and Light. And I find that these key customer indicators are really the way to overall drive your SAIDI and SAIFI metrics down, is to be really focusing on these customer indicators and outlier indicators. So I'll start off with customers experiencing multiple interruptions at Florida Power and Light. We actually measure this at 3, 5, and 8. Customers experiencing more than 3, more than 5, and more than 8. And I think one of the things we have to remember about this is just not an indicator, right? These are actually people behind the meter. And that's kind of one thing we have to get as engineers is that that's not numbers. These are customers, these are ratepayers, and they deserve better. And that's what our focus on. If you could take a look at the chart on the right, we put here since 2014, we've been really focusing on these customer indicators. And if you look at our SEMI 3 indicator, you can actually see we're doing fairly well, about 4.5%. And then we actually jump up to 5.5%. So by looking at this indicator, what we were able to glean from that is we had started in earnest our storm hardening program of our feeders. So while what this jump was is we were causing several more outages on that feeder while we were in construction due to our construction methods. Now, if you could take a look at our downward trend over the years, and I think we're now around a little bit about 3.5, you could see that we've actually tried to put a lot of focus on, you can't just say, well, we're doing construction, that's going to drive SEMI. That's not acceptable for the customer. So we put a lot of things in place to actually drive down the SEMI 3, 5, and 8 indicators. Really, to get this done is actually, we really created a specialized team in my organization of 3 people, and that's what they actually look at every single day and actually start to look at these indicators. We'll actually even stop construction on certain of these jobs if they're going to hit the 5 or the 8, right? Because that's how important it is to the customer to provide good reliability service, especially during these times when everybody is working at home, right? You have to step up your game. On for the SEM, customers experiencing multiple momentaries. I have 15 and 25. But really in 2014, that number was 35 and 50. Could you imagine being on a feeder with that many momentaries, right? And we really started to take a look at how are we going to drive the SEMI number down. A lot had to do with automation. It was the way we were removing temporary faults, a lot of fuel saving schemes, but it drove customer satisfaction in the opposite direction. So that's, again, why we went to the Trifera 2 is actually we have a great big benefit on that. We did see a lot of other issues on our feeders that we did correct. But right now, we've eliminated the 35 and 50. The goal was to get to 0 on those. We did do that. And now we've actually lowered the indicators to 15 and 25. I do expect these indicators to actually be driven down even further to 10 and 15 is probably our next look at that in probably around the 23 timeframe. Along with the SEMI indicators, I would expect us to just monitor 3 and 5 and drop the 8 as we're down to only about 1,000 customers out of the 5 million that actually experience 8 outages. Now, the one thing that we also do use is the PSC inquiries. So we take a look at how many times customers are complaining to us. And what it really kind of showed was our MAIFI indicator was really good, but our PSC complaints and inquiries were going up. And we started to really dig into that. And we actually came up with another indicator called the CME, or customer momentary experience, right? And so what we were actually seeing is, even though a feeder may have experienced some sort of outage, we were actually getting depressed voltage on the entire bus. So when you really wanted to see this, is the customers were actually right, but the indicator was misleading. And until you actually combined it with your PSC complaints, and we look at this new indicator of CME, you could actually really see that, yeah, we weren't giving great service to a lot of our customers. And why is that an impact? Well, with today's technology, with cable boxes and routers, right? All that stuff requires a boot up time of 6 to 8 minutes. That's almost like an outage, right? So now these people were complaining, and rightfully so. What we did find out is There is a correlation for us on MAIFI indicator in the CME, and it's about 2.5 times. So when you look at MAIFI, I'm sorry, CME is about 2.5 times our MAIFI. Now we're trying to reduce that. How do you drive that down further to 2 minutes? And that's a challenge we're going to go. Another thing of why we looked at this is we could actually see that you have a very small customer base. Maybe for us, it was 5 to 4% of our customers were experiencing on SEMI, but it was actually making up to 20 to 25% of our SAIDI and SAIFI indicators year over year. So we know we needed to drive that down, because every time we have one of these outages, it drives your O&M costs, right? So it's really how do we actually get better by getting better with the customers? When you started looking at the SEMI, we started looking at lower level tickets and eliminating lower level tickets and using technology and things to get better on that. So again, how we've improved on that, again, a lot of smart grid devices, a lot of process improvements. Again, a specialized team that actually just looks at this. But our biggest asset was using technology with the drones. So what we really were able to see is to use that drone technology to actually really do some really good assessments of what was going on with our facilities. And what we did find is we did have broken strands of wire, and the drones were able to pick this up. And what we were finding as a broken strand of wire, you start to think of that as an inline fuse. So when you had a fault, we were actually burning down through the conductor. Through our drones, we have been able to really proactively drive these indicators in the right directions. So through a lot of these programs and focusing on the customers, not only will we improve these customer indicators, but we've improved our SAIDI and SAIFI and traditional indicators.
Ron, thank you for that masterclass in how to address, outage and reliability problems today. Next, we're going to kind of move to the future and talk about, how we can deal with the idea that every outage counts. As we understand that, we find some options out there today that, when used as a complement to feeder level data, can actually tell us a lot more about the customer experience, which Ron was just talking about. Chris has already talked about CEMM and CEMI. A valuable blend of these two is SEMSMI, customers experiencing multiple sustained interruptions and momentary interruption events. If we were to pick one metric that could capture customer level reliability, this would be it. SEMSMI exists today in the IEEE standard, but there are no signs of it being used anywhere, really. I think it would still make sense to exclude major event days, simply to make it easier for tracking performance from one year to the next, and kind of think about those separately. But we don't have to necessarily exclude major event days entirely. While there is not yet a widely agreed upon standard, there are many in the industry discussing ways we can evaluate resilience of the energy grid. How stable is the grid in the face of major events? How quickly can the grid recover from major events? The challenge isn't treating different major events the same, since they're not. But even if our evaluation of the stability grid is less quantitative and more qualitative, the increasing major event risks posed to the grid today mean that there's a dynamic worth looking at here and targeting for improvement. Let's talk about another dynamic in terms of future technology. Looking at the future, we can see that technology is going to change system reliability and the stability game. Distributed renewables, for example, are going to introduce challenges to the grid as they start becoming a significant source of generation on feeders. Even a momentary outage lasting 5 seconds will knock distributed generation offline. IEEE standards require generation sources to remain offline for 5 minutes after they've been disconnected. Reconnecting customers to a grid that is now missing 20 to 40% of its generation, in some cases, is going to put additional stress on the grid, and it's going to reduce resilience. And it's going to take longer to build that grid back once it's down because of these intermittent challenges. The kind of distribution instability that we're talking about was actually detected in the UK right before the outage of 2019. But this is not the kind of challenge that would be identified by today's resilience metrics or reliability metrics. We need to expand our thinking around how the grid performs, what's driving performance, and how it's going to affect both people and the economy, as Chris was talking about before. So let me ask you folks one more question. Let's hear from you one more time. There is a question coming up on your screen right now. Are any of the metrics that we've discussed, are there any of those that you think would be highly valuable in improving customer satisfaction? I think it's likely that the industry is not going to be adopting all of them, but they're going to be tried in different places. And ideally, the ones that achieve regulatory goals and best serve customers are going to be the ones that will be widely adopted. Anytime we move to a new metric, of course, we need to create a new baseline. Utilities may find that their work in pursuit of positive results for something like SAIDI may not correlate well with one of these new ones we're talking about. But that's precisely the point. It's all about doing something that we haven't done before so we can identify the problems that we haven't seen before. Doing it carefully is going to allow us to have the right metric for the system and hopefully not too many unintended consequences. So we have the poll up here. I think all of these are going to be valuable. It does look like the folks on the line agree that SAIFI is going to be a nice blend for moving forward. So given that, how do we see things playing out? First, these challenges are only going to be solved by utilities and regulators working together and with stakeholders to develop new approaches to reliability. If we develop metrics and programs that are too onerous or simply create new blind spots in the system, progress is going to be slow and it's going to be expensive and probably won't be worth it. So a great way to avoid this is setting clear performance targets around reliability and other state objectives by using things like alternative rate making to ensure that utilities can pursue those goals full force while making money from their successes. Several states in the US and countries around the world are trying this approach, and so far it seems to be working well, whether that be just alternative rate making or full performance-based regulation, or as we're doing in my home state of New York, transitioning to a distribution systems operator model. Not every solution is going to be solved by increasing our investments in grid hardware. Whether it's taming demand spikes, improving power quality, or bringing systems back online quickly after a major event, there are a myriad of traditionally non-grid solutions that can be leveraged to improve performance. When utilities have the opportunity to work with industry partners to deploy non-wires alternatives and profit from the successes there, we're going to be able to harness the power of those solutions for the grid. It's all about getting the rules of the game right, having the right players on the field, and the right ways to keep score and incentivizing success. So I'll turn it back to Ron one more time. And Ron, ask, what do you expect to be most important for FP&L on this front?
Yeah, thank you, Brian. So right now, Florida Power and Light, we are not tracking either one of those indicators, CLID or the SAIFI indicator. I do think there's probably going forward, those are decent indicators to start to take a look at. But right now, our focus really is truly on, on the outlier, our outlier performance. So we really kind of make sure we have also different indicators of, we actually think that a bad restoration event is more when we have more than 120,000 CMI on a feeder, right? So we take a look at those outlier events, and then we really start to take a look at is, well, why did we have them? What's the root cause, and what's the system issue that we need to correct that we're having this outlier performance? We also have a tendency to take a look at, we also track our we have an LPHI program, which is really low probability, high impact. So we actually evaluate our systems to take a look at, you can have once an event happen, and it's a very high impact to the customer. So then how do you start mitigating that? So we actually take a look at, do we have enough ties on our feeders? Do we have enough rate, how are we feeding these substations? Do we have enough transformer capacity in the area? Some really basics we try to blend and enhance our planning process, where we start to take a look at individual system exposure. To kind of take a look at our long customer durations, all of our area managers out there have access to trying to drive that customer duration down. So if he actually feels that we're going to get more into a 4-hour outage, he's able to use a mobile generation fleet that we actually have at our disposal. And now we've actually even moved to buying a mobile generation interconnection trailer, where we can actually connect that directly onto a generation right onto the feeder itself, instead of some of the customer or even on the lateral. So we're trying to really take a look at, our focus is not to look at the indicator, but to put processes in place to try to mitigate all of this. And when we take a look at SEM and SEMI, I think our preference will always be to take those indicators and drive them down, just like what we did with SEM, I'm sorry, where we had 35 and 50, now we're at 15 and 25. I think you'll see us we'll keep on lowering those. And the same thing for SEMI, right? I think our goal has to be, you have to eliminate the 8 and you got to eliminate the 5 eventually, right? So because this is really about the customer. So that's why I kind of don't know how much value there would be in tracking the SEMZs if you're not doing anything about what you're the SEM and the SEMI, right? So you could track stuff, but if you're not acting on it, I don't know, what the real point would be. Kind of what we take a look at is also something going forward is our resiliency indicator. So one thing we noticed when we hardened our feeders and we did them storm secure, and in Florida, what that means is our distribution feeders have to handle 145-mile-an-hour winds. And the philosophy is, yes, we'll probably pick up wire, but we do not want to replace poles. And that's really what drives us. But what we also saw and took advantage of is trying to get reliability improvements while we're hardening those feeders. And what we see is a hardened feeder performs 41% better than a non-hardened feeder for us on everyday events. Along with that, we really tried to take a look at our programs on resiliency. Is what is our tropical event restoration? How long does it really take us? In 2006 is when we really kicked off our Storm Secure program. And I have a chart up here on the right. You can see our performance during Wilma versus Irma. And when you compare Wilma, which was a category 3, to Irma, a category 4, you can actually see that, we actually had more customers out. So you can say, well, how were you more successful once you implemented your Storm Secure program and you had more customers out in Irma than you did Wilma? One, it was a bigger and more powerful storm. But the thing you really have to take a look at is the next line down is where the poles impacted. So we used 12,400 poles during Wilma. We're talking, 18-day restoration on those things, right? Extremely long. But then when you take a look at Irma, we only used 4,600 poles. Now at that time, we're still only about 50% of our system is hardened, right? But we also implemented a lot of different other activities or the pole inspection program. So, and then the other one is, if you look at the number of substations we're out and how long it took us to restore a substation, we basically, now we're restoring substations in Irma. In 24 hours, every single substation was restored, and we only had 92 stations that actually we had lost power from the transmission grid. So I think all of this plays into, when you look at resiliency, I think you can't look at just the SAIDI and SAIFI, because you start to miss the TMED days, and the exclusion days actually start to skew what your performance really is to the customer, right? And that's kind of what we're looking at is, yes, even when we have storms, the we look at how much we're excluding and we're saying, you know, where did the system go wrong? Because we're trying to really get close on, you know, reducing the number of exclusion days that we do have, and also the customers, because it is all about the customer. And at the end of the day, on restoration events, is if you take a look at it, is there's a GDP impact to the state of Florida. So when we cover a large portion of Florida, when you take a look at the impact for every day that we're out, we're impacting livelihoods in the state of Florida and also the Florida economy. So by moving more to hardening and measuring resiliency above and beyond the day-to-day reliability indicators, we're really trying to bring extreme value to all of our customers in the state of Florida, whether there's good weather or bad weather. And I think that's probably where we need to be going forward, is how well is your system performing on bad weather? Just because you get to exclude it as an indicator, your customer still sees the outage, right? So I think that's, when I take a look at also with the regulation in Florida, it is a partnership with the Florida Public Service Commission, right? In 2006, they did approve our Storm Secure program for all the IOUs in the state of Florida. And now they recently just passed the Storm Protection Program Clause, where for Florida Power and Light, what that means is now we're going to be addressing our overhead laterals. It is a long program, but for our overhead laterals, we determined in the end of 16 that we could not harden a lateral and it would still be effective and get the same performance as overhead feeder. So what we have decided is we will be burying our laterals, right? And we'll be putting some more automation along in with that, because it's not about burying it. You still have outages with the underground, but we're trying to look at that one next step forward, is how to even get better when you underground it. So I think our relationship with the PSC is a joint effort in the whole state of Florida with the IOUs, and trying to get better in resiliency and providing power all the time, whether it's good weather or bad weather, Brian.
Ron, thanks for adding the real world utility voice to our discussion today. That's really good. Thanks so much. I'll take us to our final here, where we always say there's more to the story, and when it comes to reliability metrics, the more is becoming more important every day. While utilities are broadly working to improve reliability to meet the customer needs, the reliability metrics of the past are not keeping up with today's customer expectations, let alone where we're going in the future. So hopefully you took some new thoughts away from the discussion today. It was interesting to see that not too many people had heard of SEMSME at the beginning, and then at the end thought, hey, SEMSME could be a good metric. And Ron gave a little bit of a counter to that of why it's got to be blended in with other things. But no matter what your role in the industry is, you know, we hope to raise a general awareness of reliability and improving the end customer experience. So we'd love to hear your voice on this matter too. So I'm going to say thank you for attending, but I'll pass it over to Spencer for Q&A and wrap up at this point.
Excellent. And thank you, Chris. And again, thank you, Chris, Brian, and Ron, for sharing your insights today. We have a lot of great questions coming in, but just a reminder, if you didn't have a chance to be here right at the beginning, you can submit your questions via the Q&A function at the bottom of your screen. We'll try to get to as many of them as we can in the time we have here remaining, so I'll get right into it. So the first question we have is, how has customer experience influenced what utilities are doing? Chris, you want to take that one?
Yeah, I think the customers 20 years ago, I've been at this for 25 years now. So I guess 20 years ago, it seemed like momentaries didn't matter that much. And today they matter about the same as a sustained outage. So I think how the utilities, they do respond to that. Of course, it's a big system, it takes a while, but I think one thing that's happened is fast tripping on the feeder was a very common thing in the substation and along the main line. That's, now that I think about it, it's kind of a utility-centric way. It stops the fuses from blowing, so the utility doesn't have to go out there, but the customers do experience momentaries. As Ron indicated, some customers in Florida with all the lightning could get a lot of momentaries. But today, I think the difference is people are moving away from that fuse saving philosophy. There's newer technologies and take a more holistic view. It's not just the feeder, it's the laterals all the way down to the customers. So I think that alone really is trying to address the customer experience more.
Excellent. So we have a couple questions that I think anybody from the panel could address, but there's questions on where are the customer-centric reliability metrics reported?
For Florida, some of our SEMI indicators are in some of the MAIFI indicators. They are actually reported at the Florida Public Service Commission. When you take a look at the, whether it's the EIA or these, or EEI surveys and a lot of benchmarking, it's still not a lot of collection of data around customer-centric, since it's still very much the traditional indicators.
Yeah, and that's common that there are the traditional ones are usually in states across the country gathered by the regulator. There are some states that do require certain things, like there are a few states that require SEMI and things like that. But usually when those metrics are used, it's being used by the utility and might be in an annual report, but it's not required for regulatory filing.
Similar question, anybody from the panel, do you think the customer-centered metrics will ever be included in IEEE 1366?
Some of them are there already. SELID is in there, and SEMI, customers experiencing multiple interruptions. I don't think the multiple momentaries is in there though. But we've seen utilities, Florida Power and Light uses that, and some others are tracking it. So it's a mix. There's some in there already. But SEMSME is in there, but like we said, most people don't even know about that one. So it's a good reference to check out what's common in the industry, I guess.
Excellent. Another similar question is, how are these momentary numbers captured? Are they captured at the feeder level, midline recloser, or at the customer meter? So what infrastructure is being used to capture these momentary interruptions?
Yeah, so I think it really is going to depend on each utility and their capabilities to capture events on the system. Currently, we do track it at the breaker. As we move forward with our new OMS system, that it's like now we're going to be able to even track it even further down the line if you want to start including reclosers and whatnot. I think the big debate though would be how do you normalize your standard practice across all the utilities? So if one utility is only counted at the breaker and another utility is counted on every single device, the utility that's counted it more actually will skew the benchmarking data. So when you're looking at benchmarking data, you really just you got to have one rule and then you got to go with it. So I think that's a tough question to see where you can get to going forward, depending on what everybody's capability is.
Another question that's come in is, there's been a lot of examples of large utility responding to these customer-centric measures. What can public power, municipal and cooperative utilities, how does this change towards them, or does SEMSME also apply to them as well?
Well, I'll open it up, Spencer. Look, I tell you, it doesn't matter who the customer is served by. That's how I really look at it. I've been doing this for 34 years, right? So if you're really trying to provide reliable service, it doesn't matter whether you're a co-op or a municipality or an IOU. A customer is a customer in your state, right? And I think some of these metrics are very good metrics. The SEMI and the SEM are very good starting points for taking a look at how do you improve your service to these customers. And anybody, and I think we all have an obligation. It's not only to get better on reliability, but when you're doing that, you're driving down and driving out operating costs. And I think that's also a very big picture on, you will save money and the rates will get better for your customers by driving your reliability indicators in the right direction.
Chris, Brian, anything to add to that?
I would just add that it feels like some of the municipal utilities actually have more flexibility. There's a different regulatory compact in play there, and they have a little bit more flexibility to say, hey, this is really where we need to be in terms of looking at our reliability, looking at our resilience, looking at customer level metrics, because they, just because they're not some large utility with a mandate to look at this doesn't mean that it, just as Ron said, doesn't mean it won't help them. And in many cases, because you're usually dealing with a smaller area, it's probably going to be a lot easier to figure out which metric is going to help identify those challenges on the grid.
I think we have time for a few more questions. One that I think is important that we've gotten a couple different ways is that how does energy storage, either at the residential or the substation level, or neighborhood-based microgrids or larger microgrids, or non-wires alternative, I know you talked about, Brian, how does that affect things like these customer-centered measures?
Well, it can have a tremendous impact. We're not really set up for it to right now. So when we think about grid level energy storage or leveraging customer energy storage or microgrids, in many states, most states, there really isn't the clarity around ownership models for these technologies. We just had a FERC announcement that ensured that energy storage and renewables can be sold in the wholesale market. That doesn't help us when it comes to local resilience. So whether it is utility microgrids serving a particular feeder or behind the meter microgrid, we need to have a regulatory environment that makes it clear when and how those can be used and how they can be used to support the grid. Now, once they're there, whether it's a hospital deploying a microgrid or a utility deploying something at a feeder level, they can actually have a huge impact on ensuring that the reliability for critical customers stays up.
Ron, anything to add to that?
So, I think when we start to take a look at storage and other devices, I think they're going to have to be another set of indicators that everybody's going to have to worry about, right? They're going to have to start worrying about more about power quality in that area. That's kind of, and I've seen some issues, with power quality on this, and how much harmonics these devices are actually introducing. So I think it'll be something interesting going forward.
Excellent.
I think maybe where Brian was talking about grid stability or grid resiliency. We don't have metrics for that today, not at the distribution level. But any of the microgrids, energy storage, those kind of technologies can really influence it. As Brian showed with the houses that went out, it actually in the short term could make things worse by having the DG there. And that's why I think we are bringing up the fact that metrics on grid resiliency might be something we need to look into, some leading indicators for that.
Yeah, I mean, how do you want a stable grid, a clean grid, a cheap grid? There's a bunch of kinds of grids you can have, and it's like, all right, we'll pick any two. So, but when we, and that's some of the challenge here is when we focus on certain things, we can create challenges in other areas. If we want to focus on a cleaner grid with more renewables, well, as Ron said, that could introduce some harmonics and some other issues to the grid. And so then maybe we also have to think about, well, can we do to mitigate that? All right, well, more energy storage helps us here. And, so that we have many different public goods goals when it comes to the distribution grid. And the idea is, let's make sure we're not looking at one of them at the expense of the others.
Excellent. That is all the time we have for questions today. I do want to thank everybody again for participating in this. And, Ron, Chris, Brian, thank you for sharing your thoughts. Before we wrap up, I just want to remind everybody we'll be sending a recording of this webinar to all those that attended, along with the associated white paper that unpackages some of the ideas in writing versus the presentation after this event. This will include also a brief survey to provide feedback on what you thought of today's webinar. We would really appreciate you taking just a few moments to complete that. And with that, I want to thank again Chris, Brian, and Ron for their time today, and to all of our attendees from around the world on behalf of S&C, thank you for spending your valuable time today with us, and we hope you have a great day. Be well.